Today we're discussing 2 lessons, and I don't think that's going to be a stretch because I think that you'll understand this and intuitively know these things, okay? The first one, we're going to ask you, this is not on your notes sheet, okay? This is just an extra slide, but I want you to see if you can tell me, first of all, what kind of triangle do I have up here? Scalene and obtuse, perfect. You know your vocab. The second thing I want to know is if you can tell me which sides there are in smallest to largest, and then eventually what angles we have from smallest to largest. So which is my smallest side? AB. When we write a side down, we need to write it as a segment. So on your assignment today, make sure you write segments. Okay? What's next? AC, segment AC, and finally, segment BC. Let's see if you were right. Okay, everybody ready for the reveal?
Oh, we got it.
AB was the smallest. AC was the second smallest, and my largest side was BC. Okay, so you know this intuitively, you can see it. Okay, now, which is my smallest angle? Angle C. You could call it angle ACB and use the 3-letter combo. Or you can simplify it, but make sure that you show me your angle mark. Okay?
And then it's B, right?
Then which one's next? Angle B. Perfect. Okay, let's check. Okay? So you know these things. Okay? We have a theorem, 2 theorems. But they're going to confuse you when we put them in words. Don't let them confuse you. If one side of a triangle is longer than a second side, then the angle opposite that first side is bigger than the angle opposite the second side. This is on your notes sheet, okay? And it's called the longer side theorem. But it makes logical sense, so we're not going to worry about it, okay? We're not going to memorize this theorem. Yep, okay? The larger angle theorem says if one angle of a triangle is bigger than a second, then the side opposite that first angle is going to be bigger than the side opposite the second one. Okay? So this is what your assignment's going to ask you to do. Let's see, please. They want you to order the angles from smallest to largest. Smallest side, right? Opposite is the smallest angle. Okay? What's the medium sized side? So opposite it is the medium sized angle, which is our longest side. Opposite it is the largest angle. Yes. Okay. Anybody have questions on this one? Okay. What do we do if they only give us 2 angles? Yep. Subtract their sum from 180 to find the third angle. You've got to know all 3 angles. It's coming. Okay. Add these up. 61 and 59 is how much? 120. 180 minus 120. Now that we have all 3 angles, we're ready to list the sides from smallest to largest. We want to get through this quickly so you can do your assignment and be done. Okay? Yes, sir. Okay? So we look at the smallest angle and check the side opposite it. BC is the smallest side. Okay? Always works every time. 60 is my middle one. So BA or AB, doesn't matter which way you write it, but make sure you put your segment mark on top. Okay? Then my last one. Okay, easy enough? Okay, yeah, not difficult at all. Okay? Here we go. All right, next they're going to ask us whether things can make a triangle, whether sides can make a triangle or not with certain measures. Peyton, put it away. So think of these angles as being hinges. Here's my 5. Will 4 and 2 meet to form a triangle? Yeah. But what about 2 and 2? No, because what happens is they'll collapse on themselves and they will not form a triangle, will they? Okay. What about 2 and 3?
Yeah.
Will they make a triangle?
Really? No.
They'll meet in the middle, or not in the middle, but they'll meet there, won't they?
Yeah.
Okay. They'll overlap, fall on top of each other. So in order to get a triangle, you have to have 3 sides that 2 of the sides have to be bigger. The sum of 2 of the sides always has to be bigger than the third.
Oh, then that's good.
Then you're good. Because 4 plus 2 is bigger than 5. 2 plus 5 is bigger than 4. And 4 plus 5 is bigger than 2. But here's the trick. You don't have to do this for all 3 possibilities. You only have to look at your 2 smallest sides and make sure that they're larger than the third one.
Wait, like how much bigger could one side be?
Good question. Okay, so how much bigger can one side be? Well, let's look at how many of these, or some of these, and then decide. First of all, can 4, 9, and 10 create a triangle?
Yes.
Why?
2 are bigger than 4.
4 plus 9 is how much?
That's 13.
And that's bigger than 10, right? So that's the kind of work I need to see on your assignment. Okay, or you could simply say 13 is bigger than 10. And I'm not going to make you tell me that 19 is bigger than 4 and that 14 is bigger than 9. Yes. Or 5 and 7, right? 5 and 7 is actually exactly equal to 12. Put an equal sign in when we say yes or no. Will it make a triangle? No, because they will land on top of each other, right? They won't be able to meet. Okay? So 5 plus 7 equals 12, so this is a no. Okay? If the 2 smallest sides are bigger than the third, when we add them up and they're bigger than the third, then we have a triangle. That's all we're doing. Plus a hinge theorem. We got to talk about hinge theorem. Okay? Okay, now let's look at these 2. Are they going to form a triangle? No, because 8 plus 9 is less than 18, so no. I need to see more than a yes or no answer. Okay, show me the work. Okay? So, great question came up. How do we know the range? Okay, so let's think about this range of values. We have 9 and 14 for 2 of our sides. Okay, one side's 9, one side's 14. What do you think we're going to do to figure out the third side? Add them. 9 plus 14 is a total of 23, right? Okay, so can it be exactly 23?
It can be anything between 14 and 23, right?
It can be up to 23, right? But when we hit 23, then it collapses on itself. So we know that x has to be smaller than 23, but can't be exactly equal to 23. What about the other end of it? What's the smallest value that it could be? 15. 15 will work. 14 will work. 13 works. 12 would work. 10 works. 9. Okay. So we added here, right? Let's try and take 14 minus 9 to get 5. Okay, 5 would make it collapse again, wouldn't it? Okay, so for 5, we're not big enough. So x has to be bigger than 5 and less than 23. And then we get a triangle. Any number in between those is good. 5 doesn't work, 23 doesn't work, but 5.1, 6, 29, or 22.9. All of those numbers are going to work to make a triangle. Okay? Yes. Absolutely. Okay? Add them up to find the biggest it could be, but it can't touch that one. Subtract them to find the smallest it could be, but it can't be that one. It has to be bigger. It's up to you. You can say x has to be bigger than 5 and smaller than 23, and that would be okay, right? But isn't this simpler to write? Okay? And remember that when you have a greater than or less than symbol, it always wants to eat the bigger thing, right? Yeah. So x is bigger than the 5. It's trying to get the bigger guy. And it's smaller than the 23 because it's trying to get the bigger guy. Okay? All right. Hinge theorem is one more thing we have to talk about. When you think of a hinge theorem, think of a gate or think of your hand. Okay? Is this opening ever changing? No. Is the gate size ever changing? No. So this is staying the same and this is staying the same. And they should be the same distance, shouldn't they? Okay, maybe the gate's a little bit bigger because it's not going to, you don't want it to swing through. Yes, sir. BC is right. If you drew the arc, it would be an arc. Okay, in a diagram, in a architectural diagram. Okay, but notice that when this is a small angle, we have a small opening. The dog can barely squeeze out. Okay, as this gets bigger, the distance between B and C gets bigger. And as the gate opens further, that gate opening and that gate have not changed in size, but this last distance has become larger. Okay? And that's what the hinge theorem says. Okay? So when we compare these, I have a side equal to a side and another side equal to another side. So this is my hinge angle on each one. Which angle is going to be bigger?
That would be
B. Angle B is larger than angle E because the gates open further. Does that make sense? So that's the opening. Yep, that's like your opening. Okay? This is supposed to be an angle mark. Sorry. And that's going to be difficult. Make sure that you're making your angles look different than your greater than and less than symbols.
so on 11 it'd be yes, and then you put the.
I'll come to that in a minute. Okay. So the other way of thinking about it is that with your hand. Okay. Your thumb's not changing in length, and your index finger's not changing in length, right? But if we make it really, really small, we've got a small opening. The bigger we make the opening, the more distance there is between those fingers, right? Okay, same idea. So this is your hinge. Always find the hinge and then look and see what's happening on the opposite side of it. You could write it out in words. Yep. Angle B is bigger than angle E. Okay, but it's better to get used to that symbolism. Okay. All right, same thing here, right? Does everyone see that these are my hinges? E and B? Okay? Because here is a side that's equal to this side, and here's another side that's equal to this side. But the angles aren't the same. So we can't use side angle side to say that these triangles are congruent. this angle smaller than this angle, right? So how do they compare? Angle B is bigger than angle E. Or you could write angle E is smaller than angle B. Make sure that the Pac-Man's mouth is open to the bigger one. Okay? And when you say less than, you're using your left hand to make the less than symbol. Your right hand makes the greater than symbol. Okay? All right. Last question. You bet. I'm sorry. Okay? Everybody good? All right, last question. What can you conclude about the measures of A and Q here? Now they've just changed orientation, haven't they? Okay. Do we see that we have our hinge? Here's our hinge angles. Here are our hinge angles. Okay. So which one is the bigger angle? Q. So if you want to say angle Q is bigger than angle A, that's fine. Or you can say angle A is smaller than angle Q. Pac-Man's mouth opens to the bigger one. Yes? They'll either give you two sides or two angles. Okay? If they told you that this angle was 27 and this one was 26, then you could tell me something about the sides as well. And they're equal. Yep, absolutely. Okay? Now, they will give you a few problems that actually have you use variables, x's and y's. Okay? So if you end up with something like 2x plus 3 is less than 3x minus 7 as an equation, an algebraic equation comparing them, the only thing you have to worry about when you don't have to reverse your inequality unless you do what? Divide by a negative. Okay? So the inequality doesn't switch unless you're dividing by a negative. So if you're adding and subtracting on either side, you're fine. But when you divide by a negative, that's when you switch your inequality. A little review from Algebra 1. You will have to do that on your homework. There will be an expression with x's and x's. Okay? So let's say that this was what our equation worked out to be. If I want to make sure that I'm not having to divide by a negative, I want to bring my x's to this side, which is what most of you do anyway. Okay? So if I take away 2x from both sides and I add 7 to both sides, I'll end up with 10, because the x's are gone. Keep the symbol the same, because I've only added and subtracted, and I'll get an x. 10's less than x. Okay? If it feels better for you to put the x on the other side, you have to make sure that the Pac-Man's mouth is still opening in that same direction. It wants to eat the x, right? Because the x was bigger. So x is greater than 10. I took 2x away from both sides, and I added 7 to both sides. Okay? But if I had done it the opposite way, because I like to have my x's on the left side, I would take away the 3x from both sides, and I'm going to get a negative x over here. And I would take away the 3 from both sides. My symbol's still the same because I'm only adding and subtracting. But now, when I divide by that negative 1, I have to switch my inequality. And we still get the same answer. X is greater than 10. Okay? So only when you divide by a negative do you switch the inequality. Or if you're moving it to the other side of the inequality sign. Okay? There won't be many of them that have anything to do with x, but there will be a couple. All right, assignment time. Yep, let me stop my recording.